Hello guys, welcome back. Today we are going to solve another DSA problem, which is see how to find palindrome in a string. So the input is gonna be, for example, a string, and the output should be a boolean whether that the string is palindrome or not. So what is palindrome? For example, this string is a palindrome because actually when we are reading from the left and right side, it's the same. So another example of palindrome is, for example, this one, ABA is equal to ABA, but ABAC is not a palindrome. Okay, so let's try to solve it using test-driven development. So let us create the project, and let's choose the command line tools for now, and let's solve a palindrome in a string or palindrome checker. So let's save it somewhere, and let's hope that everything is set up correctly. Since we are using test-driven development, I think it's a good thing to set up the test target as well. So let's go and set up the unit test target here, and this is the palindrome checker test. So let's create, and we are getting a new test file here, but we don't need this test scheme, so let's delete the test scheme here and delete. Great. So one thing that I like to do is make sure that our test is wraps up correctly. So let's do a failing test first. Let's make it fail. Okay, so we cannot test this, right? Because the scheme is not properly set up. So we can go to the palindrome checker scheme, and let's edit scheme. On the test side, we can include the test target. And let's close, and let's hit Command U. Now we are able to run the test. So while waiting, I'm gonna explain how we can approach this palindrome. So for example, we can have like a given empty string when the program run, then returns false. And if we have like given string of A, when the programmer should return true because it's palindrome. And for example, if we have like AB, it should return false because it is not a palindrome. And for example, if we have like ABA, it should return true because it is a palindrome. Right. So how do we check this? We can first we can get the text input, and internally in our logic, in our example, we can compare our string to the its own reversed string, whether it is actually the same or not. So that's a way of solving that. Another way of solving palindrome is by using a pointer. So we could assign a pointer at the first index and pointer at the next, like the last index, and we could compare if both character at both pointer is the same. If it is the same, then we can move the pointer next to, for example, the left pointer, we could increment that, and the right pointer we could decrement that, and keep repeating that until both pointer are overlapping each other. So if it is overlapping, that means we are finished. But if it is not the same, for example, A is not equal to, for example, X, A is not equal to X, then it is not a palindrome at all. So we could just return false immediately. So let's go with the easiest solution, and then we can refactor that. So right now, test is palindrome should return false on empty string. Here, we want to have the program and need to call the is palindrome method, with the text of empty string. We are expecting the result should be false because it is not a palindrome. So let's run the test. Cannot find a program here, so we can create that program, and of course we need to create that function as well. Is palindrome, the input is a string and returns a boolean, and let's return false right now. Okay, so the test is passing. I believe we can commit for now. So is palindrome delivers false on empty string input. Cool. So let's move our test cases. So we want to test with the a input here. Okay, so test is palindrome should return true on single string, for example. So we could copy all of this and modify to our needed here, and this one should return true. So let's hit Command U, and I believe this test will be failing, right? Because we are forcing to return false here, and it is expecting a true here. So what can we do? We could start a new logic. For example, if in this case, if the character dot count or if the text dot count is only 1, then of course it is going to be a palindrome. So we could return true forcefully here. Okay, so we are already covering this scenario. Is palindrome delivers true on single character string here. So we have covered both of this scenario. How about this one? So let's try. If the input is AB, so we could copy. The test should return false on non-palindrome string here, and the setup is pretty much the same. We can copy and paste here, and I believe that should do it. So let's hit Command U, and it is passing because we are forcefully return here, but the logic is not correct, but that's fine. As long as the test pass, we can just move on, and until we meet a failing test on the following use cases. So we can commit here. Is palindrome delivers false on non-palindrome string. Okay, so right now we are happy to go with the last test cases. So let's improve our test cases again. For example, if we have like ABA, this should be a palindrome, right? So we are testing against this implementation, this expected result, and I believe we can just copy here and paste. Should return true on palindrome string, and the string that I want is this one with the given with the expected true result. So let's run the test here. Let's see what happened, and I believe that should returns a failing test here, right? And that's because we are returning false in here. So what we can do is we could grab the text from the argument and compare that itself to the reverse of itself, and this reverse is returning a reverse collection of string type, and I believe a string should compare with a string, so the type should be the same, and we can just return this directly. So let's run the test again. Okay, so we are good. We are passing this test, but we have a failing test on our very first test here, because we were returning false in a row here, but we didn't handle this logic. So this test case is for the empty string. We could handle that. If the text is empty, then it is not a palindrome. Okay, great. Now we have the current state, and let's commit. So is palindrome returns true on palindrome string. Okay, I think so far so good. We are doing it really well, step by step. But sometimes we don't want to use this reversed API because it's like very handy. We could create our own logic for this reversed, and I'll show you after this. Okay. So let's go and implement another logic beside this one. How do we do that? For example, if we have these tags here, we could compare and grab this character on the very left and on the very right. If it is not the same, it means that it is not a palindrome. We can just return a false. But if it is actually the same, like in this case, keep iterating on the right side here of the left pointer here and in here as well. So for example, if A is equal to A, then okay, continue to iterate. If B is equal to B, okay, if A equal to A, okay, and then it should be finished looping, and then it should be done. So how do we do this? So we want to keep iterating while our left pointer index is not overlapping with the right pointer index, like this, right? While this pointer index is not overlapping, then what we can do is we can check if the character at the left pointer index is equal to the character of the right pointer index. Okay, so if it is actually not equal, then it means it is not a palindrome. We can just return false immediately. But if it is equal, then we could move our left pointer one value to the right, and we could move our right pointer one value to the left, right? So we are missing some variables here, so let's create that. Left pointer index is equal to the very first index, and the right pointer index is equal to the last index here. And we still need a character here, so let's make a character. Let character is equal to the text dot map. We can grab each character on that text, on that string. So I believe that should do it. And if this loop is finished, it means that our line of code is going to go to this line, and we can just return true here, because if it is finished, then it means that it is palindrome anyway. So let's try to hit run test, and the test is succeed. So there you are. We can change our logic from the dot reverse provided by language to using our self logic here, and the test is helping us to verify quickly whether we are breaking something or not. So I think it's a good idea to commit here. So let's commit change palindrome logic here, and okay, so I don't think we need this. I think deleting this here will be the same, because the code will go through here and just return true here. So let's try. and quickly verify. There you are. The test could quickly verify the changes. So what happens if we remove this one? For example, someone in the future might accidentally delete the code, and boom, the test is going to tell us, hey, the old test is broken. So having this kind of suite of tests will help us in the future. So let's revert the changes here. I don't think I need this. It's fine. Okay, remove code. Okay, I think that's how we can implement our palindrome checker, whether we are using our own code like this or using the swift.reverse method there, by the help of suite of tests using test-driven development. That's all in this video, and I hope you enjoy this kind of content. I'll see you in the next video. Bye.